Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, so hi everyone. My name's Yu Yi. I'm presenting for the University of Melbourne. Alistair is our PI, but I'm giving the presentation today because I'm his loyal student. Right? So today we're going to talk about user intention and interaction for improving search effectiveness. Now, user intention is probably something most of you would have heard of, but quickly, it's to do with the goal of the user when they're issuing a query. Right? So when I type in, for example, Microsoft, I want to determine whether the user wanted to go to the page of www.microsoft.com or just wanted to find some information on Microsoft, probably in the form of a Wikipedia article, for example. Right? So the goal in our research is, so using past data, so past data being archive data like click-through logs, proxy logs, things like that, depicting user interactions with the search engine. So user interactions, now this is, it can be a lot of things, right? So the user issuing a query, that's an interaction, obviously, but issuing click-throughs, like in the Microsoft case, or if the log allows it, things like the user moving a mouse or highlighting or viewing certain things for a longer period of time, they also count as interactions. So we try to combine that with current contextual information. That's what we witnessing in the current, what they're currently doing, so in their current search session. Can we determine the user's search intent and use it to enhance their search experience? So we're trying to use some metric, right? So form an algorithm to determine the user's search intent, be it navigational or informational, and form it as a feature or some sort of other representation that we can use in some retrieval algorithm and improve the ranking that we're given to the user before they're actually presented the results, right? So this is, you might view it as a sort of a re-ranking problem. Okay, so to get a bit of a better idea, this is the system that we're proposing. So this, so obviously we've got the user. Now, we talked about contextual information, so the current contextual information, and the past information. So that's split into these two groups here. So the contextual information, we got the query terms. We might want to see what the user did in their current session, in their current search session. So the past click-throughs in that session, what queries they issued before, and we derive some statistics from that. Similarly, for the past information here, we got archive data. So this is where the Microsoft data comes in. So we try to derive some statistics from that and then combine those two using an intent classifier. Right? So we build some information here, we put it into a classifier, that spits out some intent features, and that gets put into the re-ranking system, which has results from an existing search engine. And then we put those together and build a new set of results and present it to the user. So the user would normally get something from here, but in this case, they're not going to see this at all. They're going to get the results after they've been re-ranked. So we're going to be, so the Microsoft data talks about archive data. We're going to try to concentrate a bit more on this because this is what we mainly looked at. Okay, so just a quick overview on the remaining of this presentation. So we're going to talk a bit about obtaining the real user behavior from the MSN data set, right? So this is the thing that we find is often overlooked because how do we know the query log represents what actual users are sitting there typing into a search engine? So I'm not too sure how many of you looked deeply into this, but we found that there was quite a lot of queries from what we suspect are machine sources. So we obviously the biggest session in the query log was about 30,000 queries long, right? And they repeat every 10 queries, which obviously shouldn't be included in any analyses because that would skew what we would deem to be real user behavior. So we did a bit of investigation on how we actually try to get the real user behavior. And we're going to talk about some discrepancies we discovered along the way, right? So some things that we think might be some might be something wrong with the data set or how it was generated or how it was represented, etc. And we're going to talk a bit about the quest for assets and the future activities. Right, so to remove the influence from the machine-generated queries like we were talking about and try to filter out as much of the bad queries so we get what we think are actual user queries, so queries by user, we chose to use the click-throughs that were provided as an indicator of a live user, right? So that's a real person sitting at a terminal issuing queries. So we think this was pretty much an essential step to make sure that we had the right stuff. Now, we took two approaches. So we used query-based filtering and session-based filtering. We're going to present results on both of these, but quickly, query-based filtering will only retain the queries with an associated click-through, right? So we're assuming that only users are capable of issuing click-throughs. Now, this might not be completely true because machines are, obviously, you can fake spoof referrer field or something like that and get it interpreted as a click-through, but we see that you wouldn't have as much motivation to do that, right? Whereas you have more motivation just to crawl the query pages and see what comes up. So query-based filtering, we retain only the queries. Session-based filtering was we retain all sessions, right, that had at least one click-through. So maybe a user issued 5 queries, but they only clicked on something in one of them. So we're going to keep all of those, and all the sessions without a click-through are going to get thrown out. Now, that's going to throw out, obviously, the things that users typed in something and didn't get a result, or they saw what they liked in the snippets, but we actually found that wasn't actually too much. It wasn't too big of a number. So we'll move on to some of the graphs that we generated. So this is the time between queries, right? So the time interval in seconds between queries within the session for query-based filtering. So as you can see, we actually get a big drop-off here. So note that this is a logarithmic scale, right? So we get a big drop-off in how quickly the users actually issue the queries. You might say that it crops the short time intervals, right? And that's probably not ideal because it forms a sort of artificial distribution, you might say. So by comparison, this is session-based filtering. Now, just out of interest, the original graph looks something like this, but we didn't include it for brevity, so it didn't have this little dip here. That was pretty much the difference. Now, from this graph, we can see that this section here, so the time between queries, we might suspect that this queries issued within 1 or 2 seconds of each other probably are machine-generated, whereas queries issued from this section here, so about 10 seconds or so, probably are actually typed by a user, right? So comparing this with the previous one, that's a pretty big difference, but we're still retaining this section here, which would normally be retained, which would be thrown out, sorry, in query-based filtering. Now, onto query resemblance. So we also looked at the trigram resemblance. So it's kind of so we're looking at the overlap, right? Three-letter based overlap between the two different queries within a session. So we're always looking at the consecutive queries, the overlap between the first query and the second one and the third one, et cetera, et cetera. Right? And so we got it here. Obviously, most of the queries are pretty much bear little to no resemblance. So easy way to visualize it is, okay, so we're seeing that most queries, so if we had a 3-word query, for example, most queries will have about 1-word overlap, right, within the session. Now, looking at the session-based filtering, we see a pretty big growth here, so in this part here, right? So because the query-based filtering actually took out queries and disrupted the flow of the session, it disturbed the flow of the queries, and that means it's pretty much looking at the first query that the user typed in and then looking at the fourth one or something, and skipping everything in between. Whereas, so we can see that the users actually do refine their queries, well, kind of gradually, right? So looking at the sessions as a whole by themselves. Okay, now this is just another graph. So because we used click-throughs as a guide, we didn't actually remove any click-throughs, so there's only one graph for this. But the time between click-throughs, this is the time interval in seconds as well between consecutive click-throughs on the same query, right? So here, the time intervals are pretty short as well, so we still get this lot of click-throughs received at very short intervals, but a majority of them will be about, I'd say, 5-6 seconds. So you can see from this that users are capable of fairly quick decision-making, right? So you can look at a list of results and just click one or click another one. And that's something that we're going to be taking into consideration for our future analysis. Okay, so I think, yeah, so here we're going to, now, when we did all these analysis, so we actually spent quite a bit of time looking into these things, this is the interesting section that we came across. So there was quite a few, how would you say, things that were a bit iffy in the results that we looked at, right? So here's a graph of the change in the click-through rank. So imagine if I clicked on, in a sequence for a given query, right? So if I search for Microsoft, I clicked on the first one, Microsoft.com, then I click on the third one, that would indicate a click-through rank change of rank +2, right? Because I went up from 1 to 3. So similarly, if you click backwards, so I click on the second one and then click on the first one, that'd be a change of -1. So we get this distribution where we get, so many click-throughs are within the first page, so we get this drop-off at the boundary, right? So users obviously don't like to go past the first page in the +10. But this was what drew our attention. So when there's a change in click-through rank of 0, that means the user clicked the same query, the same URL for a given query twice in a row, right? Now you'd expect that this would be, generally a bit lower than what you think, because obviously users shouldn't click on the same thing that much. So we thought, I don't know, it should be down here, but what we actually found from the log was that it fitted pretty much perfectly within the distribution, and we spent a good couple of weeks going over this, just making sure we didn't do anything wrong, and from what we could see, there wasn't anything wrong. So maybe it's, how would you say, an artifact of how the data set was sampled, right? Because we know that it was a representative data set instead of an actual query-by-query data set, as Evelyn has informed us. Okay. Now, this is the other interesting thing that we noted. So this was, you might recall we received, so most of you would have gotten an email from Evelyn informing that we could get another 20 gigabytes of archived page search results for queries in August, I believe. Something like that. So the top 50 queries with a snippet or something. But before that, we actually did some analysis. So we used the click-throughs as a snapshot, right? So we use the click-through to monitor changes in the URL's ranking for a given query over a given period. So if I look for, my query was Microsoft, I can monitor the position of Microsoft.com over a 1-month period. Now, you'd expect, so using those snapshots, we can see as time goes on, so this is through the 30-day period in May, queries were, so a given URL was more likely to change in position as time goes on, probably because the index got rebuilt or it got re-ranked because it was really popular, so it got pushed up a rank, or it was really not popular, it got pushed down a rank. And similarly, we get this change in rank distance. So once it changes, how much did it jump by? So now we get the same distribution where we see, URLs aren't going to jump across pages, but we saw this little peak here, right? So you notice that at the +20 and the -20 and a bit to each side, you get this kind of a little jump in. So that's like saying a URL went down 2 pages, pretty much. So a URL in position 1 went down to went to the 21st one, which would have been the first URL on the 3rd page, right? And that's although it's, this is a logarithmic distribution, so this is still 100. It still seemed a bit high, so we dug a bit deeper, and this is what we came up with. So as an example, the rank of http yellowpages.com for the query yellow pages over the collection period. Now, you'd expect something, so assuming that it should stay at number 1, which when you type in yellow pages in the query, in the search engine, you expect to get yellowpages.com or .com.au, .com.uk, etc., right? But we get these peaks here. So you get these peaks where it suddenly changes to rank 21, probably a bit higher, a bit lower. And you also get these little jumps to about rank 3 or so. We're not too sure why that happens. It probably is an error in either the way the data set is generated, which is what we're hoping, or that, well, something a bit more unlikely is that it actually went down to page 3, but we're hoping that's not the case, right? But it's something to be a bit careful of if you're doing stuff with URLs. And click-throughs, of course. Okay. So moving forward, we actually went against what Evelyn said and had 2 slides for the quest for assets because we thought it'd be a bit more helpful. So, well, as Eitan previously said, it's a pretty big data set, right? 15 million queries is nothing to be sneezed at. So the largest one I think I've seen before is about 2 million queries that had public access kind of thing. So we get a pretty up-to-date model on user search behavior in the general domain, right? So a lot of the query logs we have in University of Melbourne, they're pretty specialized. There's something taken from obscure search engine in Spanish or something like that, or it's queries issued from a specific department, or queries issued in like the government queries, like a previous Microsoft query log. So the question that we came up with is that are we actually representing real user behavior? So when we're doing this kind of research, we're talking about how users interact with search engines, how users behave. Are these query logs actually telling us what they should be telling us? Should we be putting more effort into trying to find what's actually users, right? Because spam and machine-generated queries by PhD students with a faulty API, sending queries to the MSN search query log, that might have a pretty big impact. So this is pretty overlooked, but it'll have a pretty big impact later down the line when you begin to put it into the retrieval system and getting ranking metrics, right? So that's pretty much what we talked about today. And also, this is something that we would deem to be desirable for future interactions, but we'd like to see some sort of extra data set transparency, right? So we'd like to know, how did you get this query log? Did you just take every 1,000 queries and then follow that user's actions for that session? Or, the first 15 million queries in the month of May, or like for each day kind of thing? We're not too sure. Similarly, how the sessions are engineered, how did you actually get the session IDs? And what's up with the rank of yellowpages.com going up to 21 and back within 5 seconds kind of thing. So I'm not too sure how possible that is, whether we can actually talk to the data set engineers, but it would be nice if we could. Okay, so now this is the real quest for assets slide. So, so a suggestion that we came up with, now this might infringe on some privacy things, we're not too sure on that, but would it be possible to get data collected from real users? So in the case of Microsoft, perhaps we can say we only collect data from users that have been authenticated using the live passport thing, which we all had to sign up for to connect to the discussion group, right? So can we ensure that the data we're getting is actual users? And can we ensure that, it's not just 100 guys sitting there and then we follow them for a 6-month period. We actually get a wide range of users from different demographics if possible even, but that's probably hoping for a bit too much. Now, the other thing that we'd like to see is that how can we represent user interactions as complete as possible? So this brought up the question from when we were looking at the discrepancies in what the user was seeing, right? So if I issued a query for Yellow Pages, I'd see yellowpages.com.au being represented at first. And whereas if you were from Germany or the UK, you might see a different one, right? So different users from different things, and Microsoft probably has data regarding a user's search preferences. Can we get information on what the user is seeing at the time they issue the query? So maybe this can be a snapshot of the web page using a print screen, or just a text version of what they saw in the top 20 queries, the advertisements, even, or their regions, etc. And finally, now, how can we get different degrees of representation? So can we get logs over different time periods, possibly at different levels of granularity? So can we get, for example, a 24-hour query log where we get every single query submitted to Microsoft, right? Or can we get something over a year or 6 months or a couple of months kind of thing, and then have it more sparsely sampled so it doesn't get to 2 terabytes kind of thing, right? So that's what we're looking for here. So I think, well, this forms what we discussed regarding the past data that we're utilizing. So we're gonna utilize what we receive from Evelyn, use the cache query logs, but hopefully we'll get something extra to build a better representation of parser user behavior, because that's quite critical in terms of determining the user intentions kind of thing. Future research will focus on developing the re-ranking system, right? So once we get as complete data as possible, we can build a re-ranking system, but that's something for later. And that's it.
Questions?
Any questions?
Well, I thought that was really great work.
Thank you.
So one of the observations, I think, is you're finding the logs they're real-life issues.
Yeah.
And in fact, that's true. And I worked in the phone company for a long time. The phone company has call detail records, and call detail records are cleaner than what we have here. But many of the issues you describe are going to be in any logs.
Yeah.
Now, some of them are. I think there are always going to be lots of artifacts, and the artifacts are always going to swamp out any signal that you're interested in unless you understand the artifacts. And so studying the artifacts is really important. I believe that there are duplicate records in what you have, and that you've discovered that, and that it's not due to the fact that people actually click through twice with zero latency in between, but that there actually is duplication.
Right.
I also believe that the bots are huge, which is kind of what you found. Yeah. Another thing is that I don't believe that click-through rates decay with position in a simple monotonic way, but say that the 11th position and the 21st position are going to have more clicks than you would expect by quite a bit, because for obvious reasons. And also that our pages don't exactly have exactly 10 URLs on every page. So where that bump is going to be a little fuzzy, and it'll get more fuzzy as you go farther down.
Can you elaborate a bit on why you don't have 10 URLs per page? Because that's what we've been observing, kind of.
Mm-hmm. Oh, well, it can be 10 or 9 or 11. Oh, well, they can set different defaults, but I think it's more due to artifacts and deduping and things like this that we sort of intended to send you 10, but at the last moment we decided to give you only 9.
Okay.
All right. I'm not exactly sure how that works, but I do believe that you can see other numbers other than exactly 10.
Okay, it'd be interesting to find out a bit more about that. Like,
yeah.
These kind of artifacts would help us get a better representation.
Right.
For what we're
I think there are some other data sets that we could talk about that would be kind of that would have different artifacts.
Yep.
Okay.
Can we tell them more about the sampling?
No.